You can fix the slow drain in your bathroom or kitchen with baking soda and two other ingredients you probably already have at home. Not a plumber, not an expensive drain cleaner, and not a temporary fix that stops working a week later. I'm talking about the drain that takes forever to empty, the drain you've treated again and again, the drain that keeps coming back no matter what you do. In the next few minutes, I'll show you exactly what those two ingredients are, why this method works when most drain cleaners fail, and what's really happening inside your pipes. Because the real problem isn't what most people think it is.
Here is what is actually happening inside your drain, because you need to understand this before any treatment makes sense. What you call a clog is almost never a solid object sitting in your pipe. What it is, in the overwhelming majority of household drain cases, is biofilm, a dense layered colony of bacteria, soap scum, hair protein, skin oil, and mineral deposits that adheres to the interior wall of the pipe and slowly reduces the effective diameter of your drain over months and years. Biofilm is not loose debris. It is a structured biological community that produces its own protective matrix, essentially a self-generated glue that anchors it to the pipe surface and makes it highly resistant to mechanical disruption and to the caustic chemicals in commercial drain cleaners. This was documented extensively in a 2004 study from the American Society for Microbiology examining household drain biofilm composition and resistance to standard chemical treatments. The researchers found that sodium hydroxide, the active ingredient in Drano and most chemical drain cleaners, reduced biofilm mass by approximately 30% on first application. Within 72 hours, the remaining 70% had recolonized the cleared area and returned to near original density. You are not clearing the drain, you are trimming it, and it grows back. What breaks biofilm is not caustic chemistry. It is enzymatic disruption combined with a specific gas pressure mechanism that physically dislodges the film from the pipe wall simultaneously, which is exactly what Ruth's three-ingredient treatment produces.
The treatment uses three things. The first is baking soda, sodium bicarbonate. A standard box costs $1. You will use half a cup per treatment. The second is white distilled vinegar. A large bottle costs $2. You will use 1 cup for a treatment. The third is boiling water, which costs nothing. Here is the sequence, and the sequence matters more than most people realize. Boil a full kettle of water. While it is heating, pour half a cup of baking soda directly into the drain opening. Follow it immediately with 1 cup of white vinegar. What happens next is the part that chemical drain companies have spent 40 years hoping you would never understand. The baking soda and vinegar react to produce carbon dioxide gas. That reaction does not happen in the air above your sink. It happens inside the pipe, coating the biofilm surface, penetrating the gaps in the biological matrix, and expanding outward against the pipe wall. The mechanical pressure of the gas against the biofilm physically disrupts the adhesion layer, the biological glue anchoring the colony to the pipe. At the same time, the acetic acid in the vinegar begins breaking down the protein and lipid components of the biofilm chemically. You are hitting it from two directions simultaneously: mechanical disruption from the gas pressure, chemical breakdown from the acid. Cover the drain immediately after pouring in the vinegar. A damp cloth works perfectly. You want the gas pressure contained inside the pipe, not escaping upward. Leave it covered for 20 minutes. Then, pour the full kettle of boiling water down the drain in a slow, steady stream. The heat degrades the remaining biological matrix, and the volume of water flushes the dislodged biofilm out of the pipe entirely. Run the tap. The difference is immediate. Ruth does this every 4 weeks without exception. Every drain in the house, kitchen, bathroom, utility room. It takes her 11 minutes total and has cost her approximately $4 a year for the last 4 decades. She has never called a plumber. Not once.
I want to explain why this works when Drano does not, because the chemical companies have a prepared answer for this question and it is not honest. The prepared answer is that baking soda and vinegar neutralize each other and therefore do nothing useful. This is technically accurate in an open container. In a closed pipe, it is completely wrong. The useful product of the reaction is not the acid and the base. It is the carbon dioxide gas produced by the reaction. In a confined space, that gas generates pressure against a biofilm that is already being chemically attacked by the acetic acid before full neutralization occurs. The reaction sequence inside the pipe lasts approximately 90 seconds before reaching chemical equilibrium. 90 seconds of simultaneous gas pressure and acid exposure against a biological matrix. Compare that to what Drano does. Sodium hydroxide is a strong base. It saponifies fats, turns them into soap-like compound that can be rinsed away. It does this slowly, from the surface down, without any mechanical disruption component. The deeper layers of the biofilm, protected by the matrix the bacteria produce, are largely untouched. The difference is not the strength of the chemistry, it is the mechanism. George Aldrich understood this in 1923. His report used the phrase mechanical agitation concurrent with chemical treatment to describe what the farmhouse practice was producing inside the pipe. He wrote, "The rural practice, though arrived at empirically, achieves what no commercial product of the era has replicated, simultaneous chemical and physical disruption of the adhered deposit." That sentence sat in an archive for 100 years. You just read it.